Hello dear students, welcome to YourPedia. Today I am going to discuss some questions, some series of questions which were asked in DRDO interview. As I told in the previous interview question that they will start with a simple question. From there they keep on asking the questions in multiple directions on the same concept. Okay, that question was about capacitor, and this question is a previously asked question. They started like this. Okay, and this is for an EC student. Okay, for EC aspirant this question was asked. That question is does a capacitor, yes, the question is, does a capacitor will allow sudden change in its voltage? Yes, the question is, does a capacitor will allow sudden change in its voltage or sudden change of voltage across that capacitor? What is the answer? Answer is no. Yes, it is no. Capacitor does not allow sudden change in its voltage. The immediate next question is, why capacitor does not allow sudden change in its voltage? Yes, the next question is, why capacitor does not allow sudden change in its voltage? Sudden change in its voltage. Yeah, so this can be answered in two ways. One is mathematically, another one is by using the concepts of physics. Okay, let's understand the first mathematical way of answering this question. What is voltage across capacitor? Voltage across capacitor Vc of t is equal to 1 by C integral I of t dt. This is the mathematical expression. Okay, what does it mean by sudden change? Sudden means within zero time. Then I have to put the integration limits from where to where, ma? I have to put the integration limits from 0 to 0 here. Now tell me, any current function or any I of t or any function integration from 0 to 0 is 0. Never it is non-zero. We have lots of questions extension to this one. So this way we can say R. See, there is only one function, one mathematical function whose integration is not equal to 0, from 0 to 0. Yes, Vc of t is equal to 1 by C integral 0 to 0. Suppose if that I of t is a del of t dt. Yes, I'll write here this direction. If I of t is equal to del of t, then this is not equal to 0. Then how much it is? Integral 0 minus 0 plus of del of t, that is equal to 1, that is 1 by C. So Vc of t is equal to 1 by C. Means within zero time voltage across capacitor will change from 0 to 1 by C. What is the present voltage across capacitor? 1 by C. That is changed from 0 to 1 by C within how much time? 0 time. When? If the input current is impulse current. Is it practically possible to provide that impulse current? Not possible. What does it mean by impulse current? First of all, let's draw I of t is equal to del of t, or let's write the note point. If note for sudden change of voltage across capacitor, voltage across capacitor, for sudden change of voltage across capacitor, impulse current is required. Impulse current is required, which is in fact ideal impulse. I can write ideal impulse current is required, which is practically not possible. Which is practically not possible. Not possible. Then immediate next question will be, what is ideal impulse? Yes. First question was, does capacitor will allow sudden change in its voltage or not? It will not allow. Why it is so? If we want sudden change, first of all, we have to understand what does it mean by sudden change. Means within zero time. Within zero time, the capacitor will not allow sudden change of voltage across it. It will take some time for the voltage to either to decrease or to increase across the capacitor. But if you want that, we have to provide an impulse current. An impulse current. Impulse current means it looks like this. What is impulse current or ideal impulse? What is ideal impulse? So they will ask you to draw the graph of ideal impulse. Yeah, see, first of all, let's define ideal impulse, then we draw the graph. Del of t is equal to infinite at t is equal to 0. Many people will understand this voltage across capacitor sudden change will get with help of infinite amount of current. It is not just infinite amount of current, it is an infinite amount of current within how much time? Within zero time, and it is equal to 0 at any other time. If I draw the graph of it, this is t, and suppose if this is del of t, yes, this magnitude is tending towards how much? Infinite. I am putting an arrow. This arrow shows that this current is tending towards infinite. If this current, see, what is the magnitude of this current? Infinite. Within how much time? Zero time. If we are able to provide this current practically, then capacitor will allow sudden change of voltage across it. This is a mathematical way of understanding. Another way of understanding is, suppose the interviewer, the scientist, the interviewer may ask you, can you explain this one with help of physics? Yes. Yes. Observe all of you here carefully. This is one of the very important explanation. For any energy to change, it will take some time. Suppose if you take a fan, it is rotating. If you switch it off, it will take some time for the fan to come to the rest position, or to make its speed equal to 0. Why? When it is rotating, it's having some kinetic energy which is stored in the body of the fan. That energy to become equal to 0, it will take some time. Or second example, if you are running very fastly, if I ask you to stop suddenly, you won't stop. You will take some time, some distance also to stop. Why? Because your body already attained some velocity. Your body is having velocity means you are having kinetic energy. Your body stores some kinetic energy. That kinetic energy to become equal to 0, it will take some time. Means the main point from physics is energy will not change suddenly. Any energy, you take thermal energy. Suppose you're holding a cup with coffee which is having some temperature. That temperature to become equal to room temperature, or that temperature to reduce, it will take some time, because that is thermal energy. Energy will not change suddenly is the statement. Energy will not change suddenly. Means for any energy to change, it will take some time. What is energy of capacitor? Energy of capacitor is equal to half C Vc square. Half is constant, yes, C is constant. Energy stored in a capacitor is going to depend on square times of voltage across it. Square times of voltage across it. If you come here, yes, see, EC is directly proportional to Vc square. We know that either it is inductor or capacitor, whatever may be the energy storage element, its energy will not change suddenly. Its energy will not change suddenly. Means this is not accepting sudden change. So if you want this one to change, we want this one to change suddenly. Anyhow, this is not happening change. See, from physics, we can understand that energy will not change suddenly. Therefore, voltage across capacitor also will not change suddenly. See, energy of a capacitor is going to depend on voltage across that capacitor. If you take energy of an inductor is going to depend upon current through the inductor. Energy of a capacitor will not change suddenly, therefore voltage across capacitor will not change suddenly. This is another way of understanding. If we want sudden change of voltage across capacitor, we have to provide with an ideal impulse current through it. Then immediately they will give a circuit like this, yes. So this was the question which was asked previously in DRDO interview, yes. And this is R, this is C, this is Vc of t, and the current in this circuit they take it as I of t. This is del of t volts. Now they will ask you to sketch voltage across capacitor and current in the circuit graphs. For that, first of all, we must understand, see, this is the question, extension from that. Sketch, yeah, they will give you pen paper, sketch Vc of t and I of t graphs. So they will observe your approach towards this problem. First of all, one thing anyone must understand is this voltage is an impulse voltage source. Impulse means just now we draw a graph that it will exist only at t is equal to 0. Other than t is equal to 0, it is absent. Now they will ask you like this also, please draw this circuit at t is equal to 0 and after t is equal to 0. At t is equal to 0, yes, this is at t is equal to 0. Let me draw after t is equal to 0. After t is equal to 0, I can say this source voltage is absent. If voltage source is absent, we have to replace that with short circuit. Why we have to replace that with short circuit? What is voltage across a short circuit? 0. Absent means it is 0. As it is not there, we are representing that with a short circuit. Yes, the voltage circuit source we are representing with short circuit, and this is the resistance and this is the capacitance. Yes, after t is equal to 0, this is C. Now there is some sudden value of voltage across capacitor, means due to this impulse voltage source, this capacitor got charged suddenly within 0 time. Sir, then they will ask you, sir, you said previously impulse current is required to charge this capacitor suddenly. Then here we give an impulse voltage source. Now how this voltage, how this capacitor got charged? Let's see. For that, we'll take simply, yes, one simple Laplace equation we'll take. Yes, that will represent like this. Yes, del of t means 1. Laplace of del of t is 1. This is R in ohms, and this is 1 by Cs in ohms, and this is Vc of S. The current in the circuit is I of S. Let's find the current I of S. I of S is equal to 1 by R plus 1 by Cs. You are going to get it as Cs by SCR plus 1. If you simplify it, yes, if you simplify it, just a minute, we'll simplify. Yeah, this is what we get. See, I of S is equal to how much, yes, Cs by SCR plus 1. Now take RC common. If I take RC common from the denominator, this is numerator is C and this is S by, if I take RC common, S plus 1 by RC, the CC gone, we got yes, I of S is equal to 1 by R into S plus 1 by RC minus 1 by RC by S plus 1 by RC. Yes, 1 by R, not this is 1 by R, S plus 1 by RC minus 1 by RC by S plus 1 by RC. So I of S is equal to 1 by R into 1 minus 1 by RC by S plus 1 by RC. See, this expression is not a big deal. If you know mathematics, you can do this, but they will ask you to explain the expression what we got. Okay, that is very important. Let's understand. Now I of t is equal to 1 by R into del of t minus this 1 by R square C. 1 by r square c into e power minus t by rc. This is amperes. Now, because of that impulse voltage source, there is some impulse current. Along with some exponential current. Okay, there is some impulse current. And t is equal to 0. How much is minus 1 by r square c? But del of t magnitude, how much is the magnitude of del of t? T is equal to 0. It is infinite. Okay, means at t is equal to 0, this current you see, this is non-zero current. And it is impulse current. Something is subtracted from infinite amount of magnitude at t. I'm talking only exclusively about at t is equal to 0. Why? Because this function 1 by r into del of t will exist only at t is equal to 0. Because of that impulse voltage source, impulse current is produced in the circuit. Okay, impulse current is produced in the circuit. Now, let's find Vc of t. What is Vc of s? Vc of s is equal to Va of s, that is 1 volt into output impedance by total impedance. Yes. Therefore, Vc of s is equal to 1 by SCR plus 1. So, Vc of t is equal to 1 by Rc into e power minus t by Rc volts. E power minus t by Rc volts. Observe this. If you put a t is equal to 0, at a t is equal to 0, yes, what is Vc of 0? Vc of 0 is 1 by Rc. You see, before t is equal to 0, let me draw that. See, total 3 states will take, before t is equal to 0. Before t is equal to 0, there is a resistor, there is a capacitor. We do not have any voltage source. And what is Vc of 0 minus is 0. Before t is equal to 0, it is 0. At t is equal to 0, yes, suddenly, yes, because of this voltage source. At t is equal to 0, this is present. At t is equal to 0, yes, this is present. And voltage across capacitor is how much it is. How much we got? I think we got it as 1 by Rc. 1 by Rc, yes. 1 by Rc, this is R ohms, this is C in farads. Now, after t is equal to 0, yes, that is very, very important. That is after t is equal to 0, now this voltage source is absent. This is resistance R in ohms, and this is capacitance. This is plus minus 1 by Rc. This is volts. And you know, this capacitor C in farads, this capacitor is discharging this way. See, current we assumed this direction, but actually current is flowing in this direction. That's why what we got, I of t is equal to, yes, observe here carefully, this current, this part of current will vanish after t is equal to 0, because this is impulse current. This impulse means that will exist only at t is equal to 0. If you see the remaining part, minus 1 by r square c into e power minus t by rc is the expression, yes, minus 1 by r square c minus 1 by r square c into e power minus t by rc amperes. They will ask you why this current is negative. We assumed current direction to be this one, but after t is equal to 0, as this source is absent, this capacitor is already charged to a voltage of 1 by Rc. Suddenly at t is equal to 0, because of that impulse voltage source, this is providing current in the circuit. Now they will ask you, for how much time this capacitor will supply current in this circuit? Up to 5 time constants approximately, or we can say till its total energy becomes equal to 0. At t is equal to 0, before t is equal to 0, or at t is equal to 0 minus, what is the energy in this one? 0. But at t is equal to 0, all of a sudden, yes, half into c into v square, this 1 by r square c square energy is entered into this capacitor. Now, because of that impulse voltage source, this capacitor accepted sudden change of voltage across it. For how much time this capacitor can supply in this way? Till 5 time constants approximately, or till this energy in this capacitor becomes equal to 0. This way they keep extending from one question to another question in multiple directions on the same concept. They will check your approach towards the problem and your depth of concepts, and your skill, your problem solving skill is very important here. Thank you.